D. Okay, so remember you have this here, slide number 6. I'm trying to have all the physical quantities, and then the equations there, right? Okay, and then I don't know where did we stop. So we are done with this one. So let's do some of those ones. So remember, in the Dropbox, you have the solution of those problems, except that because I update my slides, maybe it does not have the right number, but it's in the Dropbox. Okay, let's try to do number 2. And for the next pop quiz, I will try to give you extra points, if I remember. And next pop quiz is on Thursday. So we have a pop quiz today and Thursday. But Thursday I have a meeting at 3:30 online. So I will still be here. I'm still available, but I have to do hi, I'm here. Okay? Okay, so why don't you try to do this one? So the first thing you do, you translate the numbers into physical quantities. Step 1. Step 2, you make a drawing. Step 3, you think which equations you could use, right? So it says how long. How long means you need the time. Starting from rest, okay, so you translate that as initial velocity equals 0. Okay, oh, another physical quantity, 240 meters, that will be a displacement. Oh, another one, that's going to be acceleration. Okay, so that's the first step, and you check on the units. And then you can make a drawing. This one is very easy. So you have the number line. So when you start your stopwatch at t equals 0, there is no speed, okay, it's at rest. And you can put your 0 here, and then it's going to accelerate. And the other thing, you want to always show the acceleration on the top. And you have to think acceleration is like a force, right? Acceleration and force. So if the acceleration is positive, you see it's accelerating. So the force is in this direction. So it's moving 1.9 meters per second faster every second. What else do we know? We have the displacement here, 240 meters. So from A to point B. Okay, once you have done that, you look at your equation and you try to find the right equation. Okay, so acceleration 1.9, initial velocity is 0, you have V, the time elapsed, delta x equals 240. I'm going to put question mark here, and here IDK. Okay, so once you have done that, 1, 2, 3 steps, then you look at your equation, and it's easy, right? So which equation can we use? One equation with A, initial velocity, time, and displacement, that will be exactly. So initial time plus 1/2 AT squared. Okay? So it's easy, right? So this one is easy. 240 equals initial velocity is 0, 0.5, acceleration is 1.9, and t squared. Agree? Okay, and then physics stops, and then you complain to your algebra professor. Okay, 240 equals 0.95 t squared. So t squared equals 240 divided by 0.95, and you take the square root. Is that right or I did a mistake? Is it right? No, it's not right. What did I do wrong? It's not right? It's correct. Okay. Okay. So the time is 15.9, so about 60 seconds. Okay? So you have two solutions, positive and negative, but in physics, so far, they didn't find a way to go back in time. So there is no negative time. So it has to be positive. Velocity can be negative, but that time, no. Unless you prove Einstein wrong and you get a Nobel Prize. Okay, do we do number 3? It's easy. Okay, no, let's keep to number 4. See, you really have to practice on your own. The first trial for the assignment, you do it on your own. Second trial, you can look at the solutions. I mean, you pause, you look at the hint, and then you pause, and then you try to do it. And I highly recommend that you get together, right? You have a study group. It's good for resume too. Okay, a drawing first. Physical quantity. Okay, so that will be initial velocity. Jam. So jam means acceleration is going to be negative. And what is it supposing here? If it leaves skid mark, what do you think the final velocity is going to be? 0, very good. Right? Because you stop. That's why when you leave those mark on the ground. And that's going to be a displacement and question mark. Okay, so you have a car here, 22, and then acceleration is to the left. You know, if it helps if you have color pencil, for example. Like oh, but you have a tablet, so it's fine. Okay, so here it's stop. And then displacement here, 45 meters. It's a vector. You go from point A to point B. And here, final speed is 0. Okay? So you identify the physical quantities and you make a drawing. So T, A, initial velocity, final velocity, delta X, and here you have 45, here you have 0, here you have 22, and oh, that question mark, and here I don't care. Okay, so which equation do you want to use? Right, correct. Do you agree? Yeah. So final is 0. Initial is 22 squared plus 2 times the acceleration and 45 meters. Okay? And physics stops, algebra takes over, which is good if you are taking the MCAT. It's heavy in algebra. So you combine the coefficient, which is 98. So this is just algebra, right? You don't have to carry the 22 squared. That will be 242. So you get negative what, 4? Negative 5? Negative 5.4? Yeah. Meter per second per second. Mhm. Go back. It's getting scary here. A lot of empty spots. People are missing the class. Not good, not good. Number 7 here. I'm available just before the class also, if you find my office. I forgot where my office was, so I was going down and up and down and up. Finally, I remember. You just have to find the office. Once you find it, it's fine. So initial velocity v sub 0. That's going to be the acceleration. That will be the final velocity. And the time elapsed. So sometimes this one, students try to use the first equation or the last equation, but in between you have another equation. Or you can do it in your head, right? After 1 second is going to be 22, another second is going to be 20, another second is going to be 18. 5, 5, you're right. So 5, so 14. Speed up. 24. Acceleration is this way. 2 meter per second per second. So final equals initial plus acceleration times time. No. So after 1 second is going to be 16. 2 seconds is going to be plus 2, 18. Plus 2, 20 plus 2. Is that 5? So final is 24. Initial 14 plus 2 times t. Right? Okay, so you really have to practice. Otherwise, it's hard, but it's not supposed to be hard. If you practice, it's not hard. Okay, any question? Oh, no. Oh, no, it's the same, right? So this one is from the homework, and you have 2 ways to do it. And I'm going to leave it for the homework. If you have questions, I'm available after the class. It's a little bit tricky, so let me just draw it for you. You have 2 ways to do it. Okay, it's just a little bit tricky, and if you need help, let me know. But you need to make a drawing. So that will be the position. So t equals 0, the car has no velocity. So t equals 0. And then it starts to speed up. So that's going to be t equals 1. So it's getting faster. And then it's going to move even further and even faster. That will be t equals 2 seconds. And the thing that they give you is that between t equals 1 second and t equals 2 seconds, so imagine you have a stopwatch. So between here and there, the displacement is 12 meters. And there is an acceleration. So think of the acceleration like a force. And you need to find the acceleration. So it's a little bit tricky. You have two ways to do it. You can use my hint. It's in the assignment. Or you can do it in two phases, right? You can do phase 1. I'm going to write down the equation. And phase 2, I'm going to write the equation with that velocity here, v1. I'm going to call that v1. Yes, you have two ways to do it. I'm not going to do it because you have to think over it, but it's part of the assignment, okay? Okay, let's do a easy one. So let's see where are we? 2 seconds. So that's aircraft carrier. You know those big air like this, something like this, the big boat like that. And they have a jet. And those jets, I don't know how to make a jet, but they don't have much space to increase their speed. So they need to reach their speed very quickly. So they have some kind of catapult. So it's like some kind of rubber band here, which is like stretch. They let go and zoom, right? So they're gonna give it a huge acceleration. Understood? Because if you want to reach large velocity, you have two ways to do it. You need a large distance, so speed has time to build up, or you need a large force. Here they don't have enough distance, so they use like some kind of rubber band, like this, right? Like a slingshot. It's a slingshot. Okay, so do it. Don't wait for me to do it. More you do here, less you have to do at home. So that will be the time elapsed. That will be the final velocity. And that will be the time elapsed. So when it says a jet plane is launched, so it means what do you think the initial velocity is? 0. Very good, right? What's your name again? Brian. Yeah, initial velocity equals 0. And you know that because you need 3 numbers to solve everything. You need three things that you know. So if you stop here, you're going to be stuck. Constant, how far? Okay, I'm missing something here. How far? Question. How far? Okay, we can do it in 2 steps. So delta x, idk, initial 0, final is 42, acceleration idk, time elapsed is 2 seconds. So you have 2 ways to do it. How far? So which one do you want to use? Yeah, so the first one, right? Does it work? So the first one, delta x equals initial velocity is 0. Do you agree? So 0.5 A. No, we do not have A, right? So we need to figure A and T squared. We have that, so that's going to be T squared. So we can use delta X equals 0.5 acceleration times 4. So we need to find A. We do not have A. So how can we find A? Very good. So acceleration is the final velocity minus initial velocity over time. So final is 42 minus 0 over 2. So acceleration is very good, 21. So you have to do it in 2 steps, right? So delta x equals, so that's equation 2, that's equation 1. So equation 1 into equation 2, 0.521 times 4. So it's going to be 42. Do you all agree? Yeah. So make sure you help each other, right? You can work with someone sitting next to you. Connections, connections, connection. That's what they say. It used to be location, 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 but South Florida now, I'm not sure. One, two, three. Okay, do you want to do, okay, I'm going to give you some time to do it. Okay, try to do number 3. So help each other. Because if you just copy and paste, that's not good. You have to try to do it. Oh, it's a 2 phases. So make a drawing first. Let's do a drawing. Okay, do it. Don't wait for me. Do it. Accelerate with a constant acceleration. Okay. So it's gonna speed up. T equals 3 seconds. So the wording, because if you are taking the MCAT, they test your reading comprehension, like for the SAT. So you have to translate what you are reading in a drawing, and not just jump on the equations, because that's where they're gonna get you with the multiple choices. Because it says then it's moving at a constant velocity. For how long? 5 seconds, right? So on my stopwatch, it's going to be what? So here, t equals 0, 3 seconds, I accelerate, and then I move at a constant speed for 5 seconds. So what's going to be the time here? T equals 0, I start my stopwatch, I accelerate, t equals 3 seconds, and then for the next 5 seconds, I move at a constant speed. 8. Or you can really divide in 2 different kind of motion. But if you want to have the same time, same stopwatch, then you will do it. Try to do it a different way if you want. Oh, and here, acceleration is 0. Okay, and velocity here, I'm going to call that V. and here it has the same velocity. So here we have a constant velocity, and here we have an increasing velocity. So that will be your delta x1, two phases, so delta x2. Okay. Once you have done that, it's going to be easy if you know your equations. Acceleration here, no acceleration. One kinematic equation, another kinematic equation with no acceleration. Okay, and don't stare. Doesn't help. You have a tablet, which is great because you can erase and do, or notebook like me if you are old school. You have things called eraser. You see, this can. That's what I use. Okay, so this phase you're accelerating, right? So we're gonna do delta x1 equals, that will be just the first equation. Do you agree? So v0t plus 1/2 acceleration is 1, thank you. And the time is, and the time is 3 square. So delta x1 equals, so half of 9 is, do you agree? So that will be for phase 1. Phase 2, I need to find that velocity here. Can you find the velocity? So it's going faster by 1 every second. So after 1 second, how fast it's going? Huh? 2. What? Yes, 3 at the end. No, you're right. After 1 second, it's going to be 1. After 2 seconds, it's going to be 2. And after 3 seconds, it's going to be 3. So this is 3 here. Do you agree? Mm-hmm. If you are confused, you can just write the equation V. For here, you can say V equals AT, right? So T equals 2 times 1. No, 3 times 1. Acceleration is 1, time is 1. Oh, acceleration is 3 and time is 1. Okay. Okay, so the velocity is 3 and you do it for 5 seconds. So how far are you going to move? 15, very good. Okay, so that means 3 meters every second. So after 5 seconds, that's going to be 15 meters. Agree? Mm-hmm. Okay, so what's going to be the total displacement? 19.1. Very good. If you understand the meaning of speed, you see it's not that hard because that means every second you go 3 meters in distance. And here it means you go 1 meter per second faster every second. So the speed increased by 1 every second. Okay, one more. Okay, this one I think is from the homework or something like this. Let's try to do the last one. Okay, so the position as a function of time, okay, so it's a function of time equals 3.5t minus 5t squared. Okay, so it's like I'm giving you f of x equals 3.5x minus 5x squared. Except here, x is the time and f of x is the position on the number line. So this is not even a physics equation to begin with. It's oh, what do they want? The average velocity. No, it's a physics question, sorry. So do you remember the magic equation for average velocity? The one that students always forget? Of course, it's going to be delta x over the time, but also easier one is initial plus final divided by 2. We already discussed that before. Let me give you again an example, right? If you have 10 for the first test, and then 20 for the second test, and then 30 for the third test, what's going to be your average? 20, because you increase by the same amount every time. So each time you increase by the same amount, all you have to do to find the average is the midpoint, right? So for example, 10, 20, 30, 40, 50. At the center, you're going to have 30. So 30 is the average. So because the acceleration is constant, to find the average velocity, you do initial plus final, enter, divide by 2. Agree? Okay, so look at this equation here. Can we find the initial velocity just by looking at the equation? Yes, what did you say? Very good, 3.5. Remember we did something like that last time? Don't erase your memory over the weekend. You have to save it on a special USB key because we did that last time. We did that on Thursday. So initial velocity is 3.5. What's going to be the acceleration? Negative um, what's the acceleration? What is in front of the t square? Acceleration divided by half. So half of what equals negative 5? Negative 10. Agree? Do you remember we did that so many times, like on Thursday? I used the equation x equals v0t plus 1/2 at squared. So in that case, this is negative 5, and this is 3.5. So half of I don't know equals negative 5, so I don't know has to be negative 10. Do you agree?
Yeah.
So that will be V1. I'm going to put V1, V2. Oh, today it's hard. So velocity. So what's the equation for velocity? Velocity equals initial velocity plus at. Do you agree? Okay. So initial velocity is what here? 3.5 minus 10t. Do you agree? I can see in your eyes, some of you, that you already erased everything we did last week. You cannot do that. So can you find the velocity at t equals 0.3? Yes, you plug in it. Can you find the velocity at t equals 0.4? Yes, you plug in it. Can you find the average velocity? Yes, okay, let's keep that for next pop quiz. Because if you stare like this, nothing will come out. You have to do it on your own. Right, you get the idea? Okay, let's move on. But do save. So anyway, let's do some. Let's go back a little bit. Do graphing analysis. So, for example, in this case, what is the acceleration? 0. So if it is 0, that means the velocity stays the same. Example, velocity equals 5. So it means every second, okay, you're going to cover 5 meters. Agree? Okay, so then you have position as a function of time, okay, and you're going to have the position will be initial position plus 5t. Do you understand? Because there is no acceleration. So you see that here, when you have position versus time, what do you think the slope is? Look at the unit here on the y-axis. What do you have? Meters, right? So on the x-axis, seconds. So meter per second is velocity. So the slope is going to be the velocity. And the y-intercept is initial, initial position. Okay, let's see if I go back to that. Yeah, I will go back to that. Okay. Just a parenthesis for math about slope. Okay. When you have this here, so it's a linear equation. The slope is constant or not constant? The steepness, the constant, right? You have the same steepness. Is the steepness positive or negative? Negative. Here, the steepness is what? Positive or negative? Positive. It's a constant steepness. Do you have any steepness here? So that means the slope is 0. There is no steepness, so it's 0, right? 0 means none. What about here? That will be very bad. So we call that an infinite slope. You don't want that. Okay, so again, if you have I think it's also in the pop quiz, so wake up. Position versus time. What's going to be the slope? What's the physical quantity? The velocity. How do I know that? A slope is rise over run. Rise is in meters. Run is in seconds. Meter per second is the unit for velocity. Right over there. I don't hear you. Come on. So the slope is the velocity. So you all know what a slope is rise over run. Okay, you run, and then you rise, up. So you do rise over run, and what do you get? The velocity. And in that case, that's going to be 4 meters per second. What does that mean in math? It means for every run of 1, you go up by 4. Every run of 1, you go up by 4. That's the meaning of the slope. It's a rate. If you make $15 an hour, so every hour, that's the run, the rise is 15. Okay. So the equation of the motion will be what? X equals 4 T. Say it out loud. It takes the stress out, right? Do what is called public speaking. So X equals 4T. Do you agree? Okay. Let's understand what's happening here. So the position, So that's on the number line. So there is a biker on the number line. So that will be the number line. So first he's going away from home. Yes? What about the velocity here, the slope? Is it constant? Is it decreasing or increasing? The slope, the steepness. Constant. Okay, if you go ski in Florida, and the steepness is constant here, right? There is no steep. But anyway, the steepness is constant, so the velocity is constant. So what's the velocity? 2 meters per second. Yes? Rise over run. Now, the slope, is it positive or negative? Positive. Positive. So that means he is moving to the right. Positive velocity is moving to the right at a constant velocity. He's cruising. If you look here, that means he's moving on the number line, okay, away from home. What's happening between 600 seconds and 1000 seconds? Stops. Does it? Because the slope is 0. So no velocity. Is moving at a constant position, so it's not moving. So the position does not change. You see, he's resting, he's tired. What about here? Is the slope positive or negative? Negative. Negative, so that means he's moving to the left. So that means he's moving back home. And what is the slope? 1, so negative 1 meter per second. So he's getting tired. Okay, he forgot his snack. And you see the slope in magnitude is half. So he's going half as fast. Okay? So you connect the dot. It's the math, okay? Don't blame the physics here. Okay, again. I want to make sure that you understand. Okay, so we have the number line here. So what's happening here? Do we have an acceleration? No. Do we have a velocity? Yes. So if I start here, okay, we have to be careful here because I'm going to put my 0. Look at this graph. What do you think the initial position on the number line is? 10. Very good. You see? This is the time. Time equals 0. Position is 10. So that means when I start my stopwatch, this is x. So t equals 0. I can start my stopwatch wherever I want. The position is 10. Do you agree? Mm. Okay. After 1 second, where do you think it's going to be? After 1 second? 15. Very good. Do you all agree? Yeah. And that the car was already moving and the speed is constant. So after another second, it's going to be at 20, moving at a constant speed. And then it's going to be at 25. And the time is t. Okay? Now, if I want to connect to algebra, I'm going to have what we call equation of motion. So you see that you have your spreadsheet here. Time is 0, 1, 2, 3, 4. The position on the number line. So every run of 1, you increase by 5. So the slope is rise over run. The slope is 5. And the initial position is what we call the y-intercept, and it's going to be 10. So the equation is y equals mx plus b, so 5t plus 10. Isn't that beautiful? Right? It's not even calculus, just algebra. What's the slope here? 5 meter per second, and the y-intercept is 10. And it's moving at a constant velocity. Okay? I know one of the graph in the lab, you're going to use something like, it's like a spreadsheet. So look at this one. What's happening here? Do you have an acceleration? No. No acceleration. Is it moving at a constant velocity? Yeah. Yes, because every second it's covering the same distance. Do you agree? Okay. But, is the velocity positive or negative? Negative. So it means it's moving to the left. Right? So you see, t equals 0, it's going to be at 50. T equals 1, it's going to be at 45. T equals 2 is going to be at 40. So what's the slope? -5 meters per second. Very good. Aren't you so happy that you learn algebra here? It's very useful here. -5. Run of 1. -5. Okay, so the slope is -5 meters per second. Initial position is 50. So when you start your stopwatch, you're already moving here. You are moving here with 5 meters per second in magnitude, but you are moving to the left. Agree? Yeah. So that will be the kinematic equation when there is no acceleration. So what's the kinematic equation? No, don't fall. Position, the position at a given time equals initial position plus velocity times time. If there is no acceleration. Okay? Well, nothing new under the sun. It's the same stuff that we massage and malax. But I need your help. You need to review on your own. So constant velocity, the distance traveled, does it increase with time? No, because it's a constant velocity. So it's gone, I don't hear you. See, right? It's the same for every second. Does it make sense? Right? Okay, what now if we do have an acceleration? Now every second it's going to cover more and more and more distance. Okay, so I will show you, but just to review, so this is a parabola. Agree? Yeah. Okay, do you know the tangent? Tangent at a given time, it's a slope. Here, you take the slope. So you start from here. What do you think the slope is here? 0. And what's happening to the steepness as you move along the curve? Getting steeper. Exactly. It's going to get steeper, 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 steeper. So you take your hand, you see, you start like this, you go steeper, steeper. So you are following the curve, right? So the slope increases. The slope at the given time, this is what we call the instantaneous velocity, the velocity at a given time. So at t equals 20 seconds, what's going to be the slope? How do we find the slope? Rise over run, so it's going to be about 26 divided by 5, that's going to be 5.2. So at that point here, that's going to be your velocity. Okay? I'll give more examples. So now, what's happening when you are spinning up? And I'm connecting the dot with your first kinematic equation. When you start your stopwatch, let's say that you are here at position 10. Agree? When you start your stopwatch, your velocity is 5. Agree? Mm-hmm. Now let's say the acceleration is 2. So that means you increase by 2 every second. So at 5 meters per second, after 1 second, how fast you are going?
7 meters per second.
7. And then you're going to go at 9. And then you're going to go at 11. And then you're going to go at 13. So the speed increases by 2. Okay? So that's why I have this equation here. You see, velocity at t equals 1 is going to be 5. At t equals 0 is going to be 5. 1 is going to be 7. 2 is going to be 9, and so forth and so on. What's going to be the slope of velocity versus time? For a rise of 1, what's going to be the a run of 1? What's going to be the rise? 2. So the slope is 2. Okay? So if you do a graph, velocity versus time, the y-intercept, it's going to be your initial velocity when you start your stopwatch. So that's going to be 5. Okay? And what do you think the slope is? Acceleration. How do I know? You see the rise is meter per second. The run is second. So meter per second is the acceleration. What's going to be the equation? What's the y-intercept? And in that the y-intercept here, it's going to be the initial velocity is 5 plus the slope 2t. You see? That's a kinematic equation. Okay? Let's look at the position on the number line. So first you are here and you move to there after 1 second, but you are moving faster. So every second you are covering more distance, more distance, more distance, more distance, and you get a ticket because you're going too fast. Okay? So you look at the position versus time and you're going to get a parabola. The position on the number line, if you are accelerating at a constant rate, you're going to get a parabola. And what's the equation of the parabola? It's going to be initial position is n plus v0t plus 1/2 at squared. So you should be able to switch from what's going on in the real life, what's going on with a spreadsheet here, what's going on with a graph. So it's all algebra. Physics is just this using math to describe the motion of an object on the number line. Okay? So let's see if you are with me. What's going on here? Is it moving? Not moving.
Mm-mm.
So if it's not moving, do you have an acceleration? No. What's happening to the position? Stays the same. Very good. What about here? Do you have an acceleration? No. What about the velocity? If you have no acceleration, it stays the same. It could be 0. In that case, it's not 0, but the velocity stays the same. Agree? And then when you have position versus time, what's going to be the slope? The velocity, because I have meter per second. The slope is constant. The steepness is constant. Agree? What about if you have a constant acceleration? That means the velocity, what's gonna happen to it? Increase at a constant rate. I have a line, y equals mx plus b. What's happening with the position as a function of time on the number line? You get a parabola. Okay? I have an app somewhere, but I need to find the app and know where it is. Okay, let's do okay, let me find the app and why don't you try to do this one? So you need to find the equation of motion here and here. And you need to find the velocity as a function of time here and there. So you don't stare, you do. And then we can move on. So that's... But you really have to practice on your own, okay? You have to study from the textbook. And if you plan to take the MCAT, do the problem as we go along. So at least it will motivate you. So position as function of time. So let's find, so can we find the slope here? Let's take 2 points here that are convenient, maybe here and there. So what's going to be the rise? Okay, what's the run? 10. Okay, so what's the equation? X equals, the y-intercept is 10 plus, what's the slope? No. Yes. You're right. No. Yes, 1/2, right? Yeah. Okay, 1/2 t. So what does it mean? It means that the initial position is 10 on the number line and the velocity is constant, and it's going to be exactly. You see how it works? So on the number line, when you start your stopwatch, the position is 10, and then you move at a constant velocity, so to the right, at that rate. Okay, and here, okay, same thing here. Let's see, let's try to find the slope. The rise, it's like a fall, is 10. So it's -10, and the run is 15. So x equals, y-intercept is 0. The slope is what? 10 divided by 15, and you have a minus t. So that's going to be the velocity. Agree? The velocity of the position versus time is, you always have a, for test number 1, a question like this, right? The slope of position versus time is the velocity. The slope for velocity versus time is the acceleration. So what's happening here? X equals 2t squared. It's a parabola. So is it moving at a constant velocity or is it spinning up? Spinning up. Spinning up. Can we find the acceleration? So this is half of the acceleration. So the acceleration is 4. Right? Half of what equals 2? Initial position is 0. Initial velocity is, you don't have a term with t, so initial velocity is 0, because do remember the kinematic equation, the x equals, or delta x equals v0t plus 1/2 at squared, right? Do you agree? So there is no initial velocity, and you can see the slope here. So you see the slope is 0. The slope increases, the slope increases, the slope increases, the slope increases. So it's going to move faster and faster and faster, but at a constant rate. So the slope between here and there, for every second, it's going to increase by 4. Okay, so what do we think? Okay, so talk to each other. We're talking about velocity versus time. So the slope is meter per second per second. So the slope is the acceleration, right? Yes? So in which case do you have a negative acceleration? Negative constant acceleration. Huh? C, do you all agree?
Yeah.
Okay, the steepness is constant, so acceleration is constant, but it's negative. So if both the velocity and the acceleration have the same sign, it's going to speed up. If one is negative, the other one is positive, it's going to slow down. You can see the sign of the velocity here. You see here it's positive, 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 and here velocity is negative. So here it's going to slow down, stop, and then speed up. But speed up to the left. Okay, what's happening here? Can you talk to each other with train number 1 and train number 2? Position on the number line as a function of time. Train number 2. Is it moving at a constant velocity or the velocity is it changing? Constant velocity, very good. The steepness is the same. What's happening to train number 1? Look at the steepness here. You take your hand, so it goes like this, 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 this. So what's happening to the steepness? Like the steepness, you start here, like this. Look, the curve is doing this, right? So the steepness is doing the same thing. So what's happening to the steepness? It decreases, right? Because you get to a flat. So that train is slowing down. And what's happening at that position here? Same position at the same time. So they cross, right? So first this one is ahead and then slow down. So this one's going to catch up. So at that point, they're going to meet each other. So typical problem that you might have, something like this. You have two cars, right? So it's always with the police officer. So the police officer is in blue and is hiding here behind a tree. And you are cruising, but way, 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 way faster than the speed limit. So the car, that's your car in red, and you are moving at a constant velocity to the right. The police officer is at rest. You are moving, the police officer is at rest. So he has his special gun to measure the speed. Sees that you are going too fast, so it's accelerate, constant acceleration. And then you see the position as a function of time. Is it a line or a parabola? Parabola. So the police officer is going to catch up on you and give you a ticket. And how do we find that time here when you get the ticket? That will be two equations with two unknowns. One equation is for the parabola, one equation is for the line. Okay? So it's a real life example. So the slope of position versus time, that's going to be velocity. Do you all agree?
Yeah.
Okay, let's look here. Make sure that everyone is on board. Now if I can make it bigger. So I'm going to take acceleration of 1. So what do you expect for the velocity? The velocity increase, but the slope is constant. So it's going to be a line. And for the position, it's going to be a parabola. So at t equals 0, it's here. And you see, it's gonna it's gonna speed up, speed up, speed up, speed up, speed up, speed up. That will be x equals 25 meters, x equals 50 meters, so it's speeding up. Okay, you see how it works? And you can find the equations of kinematics. Okay, so position as a function of time. Okay, now you have to think. Don't tell me the solution right away. What do you take your hand? Look, follow the curve. What's happening to the steepness? Decreasing. So this is 0. Huh? This is a big steepness, and that's going to be 0 steepness, right? So what's happening? Decrease. Decrease, right? So what's the answer? What's happening here? Slow down. The car is slowing down at all time because you look at the steepness. Steepness of position versus time is the velocity. Okay? Okay, so that's the same story again and again, but what's happening now? Look at the acceleration. Negative. But the velocity is -5. So at t equals 0, velocity is -5. After 1 second, what do you think the velocity is? It's going to change by -2 every second. So it's going to be -5 and -2. It's going to be -7. Another example, second, it's going to be -9. Another second, it's going to be -11. So look at the magnitude of the velocity. Are the numbers getting bigger? Forget about the sign. Is it going faster? Yes, it's accelerating, but it's accelerating to the left. Okay? And so acceleration is negative. Velocity is increasing in magnitude, but it's negative. So what's happening is moving to the left, but it's speeding up. Okay? The position, when you start your stopwatch, position is 50 on the number line, and you get faster and faster and faster. Okay? You don't have to worry about it. But why is it going to be important? Because when we get to free fall, if I drop that notebook, is it going to move down at a constant speed, or is it going to speed up? Speed up. Speed up, right? So acceleration is negative. Velocity is negative, so it's speeding up. Why is the acceleration negative? What is the force acting on that? Gravity. And gravity is always down. So acceleration will be always down. So it's gonna speed up. What if I throw something in the air? What's gonna happen? Slow down. What's happening here? Stop, and then okay, the acceleration is always down. First, it's gonna slow down, stop, and then it's gonna increase. So this is happening here. When you throw something in the air, you see the speed is gonna decrease, stop, and then increase again. But the acceleration is always down. Let's do that together. Look, it's not hard. Okay, and then I stop with that. Initial time, the velocity is 10. So it means you are on a planet. On that planet, the acceleration to gravity is -2. So you take your book on that planet and you give it momentum. So initial velocity is 10 up. Okay? After 1 second, what's going to be the velocity? 8. 8. Another second. 8. Another second. Another second. 2. Another second. What happened? Stop. Let's keep going. Another second. -2. Another second. Another second. Another second. Another second. -10. So it's symmetric. You have a symmetry here. Right? Start at 10, stop, and then you have 10 again. Isn't that cool? And that's a parabola, but upside down. Okay. So let's do the real thing. So acceleration due to gravity in the SI system is -10, which means that if you drop something, it's going to speed up at a rate of 10 meters per second every second. Yes? If you want to understand what it means that the acceleration is 22 miles per hour per second. Which means that if you fall for 1 second from rest, so I go to the first floor, I don't know, I'm spacing out, thinking about physics, oof, I step out and I fall for 1 second. What will be my speed when I hit the ground before I hit the ground? 22 miles per hour. Very good, 22. If I go to the second floor and still, I space out, thinking about astronomy, I fall for 2 seconds. What's going to be my speed? 40. 34. Start to be very hard, right? And 3 seconds, I go to the third floor, and you don't have a physics professor anymore, right? 66 miles per hour. So it's not the fall that kills. Yes, right? Because then you go from 66 miles per hour, boom, to 0. So that means the force will be up. It's huge. It's going to break your bones, right? God forbid. Okay. So let's look at this. You have an initial velocity of 20. You throw that in the air. Acceleration is -10. So can you find the kinematics equation? Except that we are not going to have x anymore. We're going to have y. So we have a y-axis. So y-axis here. So we want to know how to predict the position on the number line of the ball as a function of time. And we want to predict what's going to be the velocity as a function of time. So what is given to you? Initial velocity is 20. Because otherwise, if you don't give an initial velocity, it's not going to jump on its own. You need to keep some momentum. Acceleration is -10 because gravity is down. And when it stops is 0. And then it comes back. So velocity equals 0, I can use that to find the maximum height. That's going to be the next step. For now, I just want the equation of kinematics, meaning the position of y on the number line as a function of time. Okay, so look at your equation sheet again. Except the equation sheet that you have, on Canvas, the delta S, it's given like delta S. The delta S, now it's going to be a delta Y and not a delta X. Delta S can be delta Y or delta X. So, equation is always the same thing. 0t plus nya nya nya, nya 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 nya. And that could be a delta X if you are horizontal, or it could be a delta Y if you are vertical. So I should put a delta here. That will be the displacement, right? That's a displacement here. So plug in here. So what's going to be the initial velocity? 20. So 20 t plus 0.5. What's going to be the acceleration? Very good. And t square. So each time you have a constant acceleration, there is always a square here. Okay, it's a parabola. So this means final position minus initial position equals 20t. Half of 10 is what? Right. 5, so negative 5t squared. And what's the initial position here? When you start your stopwatch? Yeah. 0. So y equals 20t minus 5t squared. Okay, so that's a free fall situation. The only force acting on it is the force due to gravity. Okay? Can you find the equation for V? So V equals V0 plus AT. So initial velocity is 20. Acceleration is negative 9.8 or negative 10. Conclusion, if you throw something in the air, you can predict the position after a given time. You can predict the speed after a given time. Okay? Don't space out. Don't do like me, right? Okay. T equals 0. What's the initial velocity? Okay. T equals 1. Velocity is 10. T equals 2. 0. T equals 3. T equals 4. 20. Isn't that beautiful? The universe or nature, like whatever you call it, loves symmetry. So you start with a 20 up, you decrease, you stop, and you end up with a 20 down. Isn't that interesting? Symmetric in the universe. And then how long does it take to go up? How long does it take to stop? 2 seconds. Okay. How long does it take to go down? How long is it in the air? 4 seconds. And how can we find the maximum height? By saying that the maximum, the final velocity is 0. Okay, typical question to trick students on a test or whatever. MCAT, for example, they will try to trick you. And they say, at the top of the trajectory here, when you throw something in the air, the velocity is 0, you go like that. Do you agree? Velocity is 0. Do you agree? It stopped moving. You see it going in space? Give some company to the poor 2 astronauts. They told him that you're going to be for 8 days. Not just kidding. You're going to be for 8 months and don't complain about it. It's for your safety. Terrible story. So velocity is 0. But listen to that. Can I say that the acceleration is 0 at the top? No. Typical tricky question. Gravity never, ever gives up on you. It will always pull you down to earth, right? So the acceleration is never 0. It's always negative 10. Okay, because it's the weight. Oh, look at that. Yeah. We're done. Any question about kinematics? The secret is to study because we don't have enough time together. So you need to study free fall. Okay, so free fall is still kinematics 1D, but now instead of moving sideways on the number line, you're gonna go up and down. Okay, in this case, it's even easier because the acceleration will always be -10. Very good. Okay. Always, always, always -10. Okay. So cats, they love to knock things out, but that's because they are scientists, right? They are studying gravity. So that takes you back to Galileo. And he said, I mean, he didn't say it, he showed it. He was able to do experiments that regardless of their mass, if you take two objects and only gravity is acting on them, so there is no air resistance, they will reach the ground at the same time. The acceleration for both objects will be -10. So it's called G. So the magnitude is 10, -10, negative because it's down, 10 meters per second, or 22 miles per hour per second, or 32 feet per second. Okay, the only reason it doesn't work on Earth, it's because we have air resistance. But if you take too heavy stuff, like you take a ball, like could be like a demo if you want extra credit, you take a bowling ball, it's kind of heavy, or you take two weights, right? Like you go to the gym, you have a 5 pound and you have a 10 pound, right? You drop them at the same time from the same height, watch for your feet, they will reach the ground at the same time. Okay, so that experiment was done on the moon, except if you believe that we've never been to the moon. Some people believe that. I think we went to the moon, but so that experiment here. So that experiment was done in 1971. The mission was Apollo 15. So he took a hammer, David Scott was his name, and a feather, and he dropped them from the same height on the moon. So it's a very famous video. It's an old video. And when you have a radio signal coming from the moon, there is a lag, right? Because it takes about 1.3 seconds for the light to reach us. Radio signal take 1.3 seconds to reach us. So you can hear some kind of lag. Okay, I don't know if I have the sound. Come on, come on.
Jim, we copied a.
No, I don't have sound. I don't know how to make the sound. Can you hear with my computer?
Solar wind and.
Yeah.
Drum in the ETB.
Not quite yet. I haven't put the solar wind in yet, but I will shortly. I want to watch this. You have a good picture there. I've got
Beautiful picture, Dave.
Well, in my left hand I have a feather. In my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? Which proves that Mr. Galileo was correct in his findings.
Isn't that cool? Yeah. But you don't have to go to the moon, right? You can. There is this. It's called a demo, the penny and the feather. So you take a chamber like this, like a tube, and you take a pump. You take the air out, right? And you make a race between a penny and a feather, and they will reach the ground at the same time. So I'm going to accelerate maybe.
Common with electrolytic feedback. We have to take all forces except for friction.
So it's a very famous demo. I used to have one, but here I don't have one. So you have this chamber here, and you're gonna pump the air out, and you have a penny and a feather. Of course, in the atmosphere, the penny will come first and the feather second because of air resistance. So he's taking the air out. So you understand why we don't do demo in class? It takes forever. So it's a vacuum. So partial
The feather and penny are just sitting on a trapdoor. No air between them and the bottom of the chamber. All that's left is to release the trapdoor. 3, 2, 1.
Isn't that cool? Okay, so conceptual question, even for the MCAT, a penny and a feather reach the ground at the same time as long as you neglect the resistance. But even more, I'm watching the time for the pop quiz. But so this is in the US, and they have this chamber, the huge one, and that was used for nuclear test. And the walls are very thick because otherwise everything can collapse. The pressure, the atmospheric pressure is like 15 pounds per square inches. So it can squeeze you, but we have the same pressure inside.
This is NASA's Space Power Facility near Cleveland, Ohio, and it is the world's biggest vacuum chamber. It's used to test spacecraft under conditions of outer space, and it does that by pumping out the 30 tons of air in this chamber until there are about 2 grams left. And it's got an eccentric construction, which is part of its history. It was built in the 1960s as a nuclear test facility to test nuclear propulsion systems. And that meant that they built it out of aluminium to make the radiation easier to deal with. Aluminium is not the best thing, the strongest material to build a vacuum chamber out of. So they built an outer concrete skin, which is part radiation shielded and part an external pressure vessel, so that this thing can take force that's present on the outside when it's pumped out to the conditions of outer space. Galileo's experiment was simple. He took a heavy object and a light one and dropped them at the same time to see which fell fastest.
That's with air resistance, right? Do you have air resistance?
Now in this case, the feathers fell to the ground at a slower rate than the bowling ball because of air resistance.
So now they close everything. They remove the air. And wait.
8, 7, 6, 5, 4, countdown, 2, 1, release.
Wow. Isn't that amazing? Look at that. They really fall at the same rate. So acceleration is -10 for both, regardless of their mass.
They came down exactly.
Exactly what I was saying. Exactly right. Nothing. That's just.
You see how, even though he's a famous physicist into string theory, he gets so excited about it? That's what you want to stay, right? With the same child mentality, right? Oh. And then he's going to explain that the reason